So guys, we are done until the listen system call. Then the next step that we need to discuss is initialize and fill the read FDS set. So you can see that we are done with the listen system call. Now server enters into the infinite loop for servicing the client. Now server has the property that they are always has to be in the position to service the client. So server has to be up 24/7, and that is the reason that the server logic are usually implemented inside a infinite loop, that is while one loop. Right? Now remember read FDS set. Now remember read FDS is nothing but it is a set of file descriptors. So using the macro fd_0, this is the standard macro which is provided by C library. So we can use this macro to empty or drain out the read FDS set. That is, we are initializing the file descriptor set. After that, we are adding only the master socket file descriptor to this set. So fd_set is the macro we should use, and this macro will add master socket file descriptor to the read FDS set. Right? So coming to the line number 91, we are now invoking the select system call. Right? So by the time we reach line number 91, the read FDS set contains only one file descriptor, and that is master socket file descriptor. Right? Now let us discuss the synopsis of the select system call. The synopsis of the select system call says that the first argument of the select system call should be 1 plus x. 1 plus x, where x is the maximum value that is present in the read FDS set. Right? So this is the first argument of the select system call. So here you can see that in the read FDS set, the only file descriptor that is present is the master socket file descriptor. So x is equal to master socket file descriptor. So the first argument is master socket file descriptor plus 1. So such is the synopsis of the select system call. Right? And the next three arguments of the select system call you can pass as null, null, null. We don't need to discuss the rest of the three arguments of the select system call in this course. So remember that the select system call is a blocking system call. The moment the select system call is invoked, this process or the execution of this program halts at line number 91. You can see that the Linux operating system keeps this process blocked until the data arrives on any of the file descriptors present in the read FDS set. Now in this example, the only file descriptor that is present in the read FDS set is the master socket file descriptor. And master socket file descriptors are used to detect new connection requests from new clients. So it means that the select system call is monitoring only the master socket file descriptor, and because only the master socket file descriptor is being monitored, it means that the select system call is blocked until the new client connection request arrives to this server. Right? So our server is blocked in line number 91. Now let us say at some point of time in future, some new client has sent the connection initiation request to our server. When this happens, our server process will get unblocked from line number 91 and the execution of this program resumes. So in line number 94, we are checking using the macro fd_is_set. So this macro is used to test which file descriptor present in read FDS set is activated. Now in this example, the only possible file descriptor that could be activated is the master socket file descriptor. Therefore, this if condition will always be true. When we will be discussing the more complicated implementation of TCP server in the next example, then you will see that fd underscore is set is a useful macro, and it is necessary for us to check that the select system call is unblocked because which file descriptor is activated. So we need to find that particular file descriptor which is activated. So in this example, this looks pretty much obvious that we are checking the master socket file descriptor, that we are checking whether is it the master socket file descriptor that is activated, and it looks obvious because in read FDS set the only file descriptor that is present is master socket file descriptor. So anyway, when this condition is true, it means that our server has received new connection request from the new client, right? In this diagram, we are here and we are checking that is master socket file descriptor activated. So in this example, yes, the master socket file descriptor is activated. So the next thing that our server needs to do is to establish the connection with the client by calling the accept system call. Right? So we are on step 7 now, that our server is now invoking the accept system call, and after the accept system call is invoked, then the connection with the client is supposed to be established. So the return value of the accept system call is the communication socket file descriptor, and using this communication socket file descriptor, our server will carry out all the future communication with the client. So basically this communication file descriptor represents the connection with this particular client which has just connected to our server. The second argument of the accept system call is the empty structure. We discussed it when we discussed the synopsis of the accept system call, and as soon as the client comes and get connected to our server, this structure gets filled up with the IP address and port number of the client. Right? So now our server knows that with whom it is talking to. Right? So our server will use this information to reply back to the client, because at the end of the day, our server needs the client IP address and port number to send the packet back to the client. And the third argument is a constant, which is the size of struct sock ADDR structure. So when the accept system call fails for some reason, it returns a negative value. So we are just checking here that if the accept system call fails, then just terminate the server process. Right? So we are here, and at this point of time, the connection with the client is established. So our server process simply printing the client identity. So it is printing the client IP address as well as the client port number. So the C APIs provides us this inbuilt functions, that is init_n2a. It is used to print the IP address in a.b.c.d format, right? And we are printing the port number of the client. So you can see that in these steps we are finished till step 7. That is, we have invoked the select system call and waited for the client connection request, and the server has accepted the connection of the client. Now the next thing that our server needs to do is to wait for the data request from the client, and when it receives the data request, it processes the data of the client, and accordingly it reply back to the client with the result. So let us see how step 8 is implemented. Now the server is again entering into the infinite loop, because our server will going to talk to this client indefinitely until or unless the client sends some special data to the server, and by analyzing that special data, our server then chooses to terminate the connection with the client. Right? So at that point of time, we will just break out of this loop. So let us see that how server exchanges the data with the client. So the first thing that the server does is to prepare a memory in which a server can store the data that is sent by the client. right? So once the data buffer is now ready to fill up with the data that is received from the server now invokes the receive from system call. Now receive from system call is again a blocking system call. If you discuss the synopsis of the receive from system call, the first argument to the receive from system call is the communication file descriptor. So remember, all the data exchange between the server and the client happens on the communication file descriptor and not on master socket file descriptor. The second argument to the receive from system call is the data buffer in which the server will going to store the data that is sent by the client. The third argument is the size of this data buffer, that is how many bytes long is this data buffer. The next argument you can always pass as null, we don't need to discuss this argument. And fifth argument is actually the client information, which the accept system call had filled with the client information. And the last argument is again the size of struct sock ADDR structure. So when the server invokes the receive from system call, it means that the server is now waiting for the data request from the client specified in this argument, right? And unless the server receives some data from this client, the server will stay blocked on receive from system call. So basically at this point of time, that is in line number 125, our server is now actually waiting for some data to arrive from this client, right? Now let us suppose that the client has actually sent some data to our server. So when our server will receive the data from this client, our server will going to get unblocked from the receive from system call. The return value of the receive from system call is the number of bytes that is sent by the client. So here we are just printing that the number of bytes that is received from the client is these many bytes, and we are printing the client IP address and the port number. Now here we have taken it as a special condition that in case the client sent us the zero number of bytes, then the server will assume it as a termination condition. That is, the server will conclude that the client do not want to communicate with server anymore. So the server closes the connection with that particular client and the server comes out of the inner while loop. But in this case, let us suppose that the client has really sent some data to the server. So the data that is sent to the server is actually stored in the data buffer, right? Now